back to my online teaching platform. We have to differentiate the function 1 out of x from the first principles. So as we did in relation to polynomials, we learned how to differentiate polynomials, that is linear function, quadratic function, cubic functions, and the other functions, just that we are restricting ourselves to up to cubic functions. So we did a lot of examples in relation to those ones. So in this video, we shall look at how best we can differentiate a rational function from the first principle. So let us start with. So given a function in this form where the denominator is not equal to 0, the function is considered to be a rational function. So the function is y is equal to 1 divided by x, which implies that our original function, which is f of x, must be equal to 1 divided by x. So let us look at our f of x plus h, our f of x plus h, which means that we are just going to plug in x plus h in place of x in the given function. So it's going to be 1 divided by, so wherever you see x in the original function, you put x plus h right there. So here becomes x plus h. And this will give us our f of x plus h. Alright, so we can now state our formula to be from the first principle, the formula that you'll be using, know it to be dy dx must be equal to the limit of our f of x plus h minus our f of x all divided by h, which is the small increment in the x value as the h approaches 0. Alright, so this is what we'll still use to find the derivative because we have to use the first principle. So we know our f of x to be 1 divided, f of x plus h to be 1 divided by x plus h, and our f of x to be the original function. So let us work on the numerator of the formula. So that is f of x plus h minus our f of x. So let us work on this part, which will be equal to 1 divided by x plus h, then minus our f of x, which is the original function, then 1 divided by x. Let us simplify this. So this will give us, let us find the LCM. The LCM is x multiplying x plus h. The LCM becomes the product of the denominators. So that's what we are using now. So when x plus h divides the denominator, the new denominator, we are going to get x. So we use the x to multiply its numerator. So that will give us x over here. Then minus. Now you'll be using the x, which is the denominator of the second fraction, to divide your LCM, and that will give us x plus h. And you are going to use that x plus h to multiply -1. So x plus h in one bracket. All right. So this will lead us to x minus h, then all divided by x squared plus xh. So this becomes our f of x plus h minus f of x. All right. So now let us put the component into the formula. So we have our dy dx, which is equal to the limit of, so our f of x plus h minus the f of x is x minus h, all divided by x squared plus xh. But in the formula, we have everything divided by h. All right, so we have as h approaches 0. We continue to work on it. So you will see that we have x here minus x, it becomes 0. So we are going to get a limit of negative h divided by x squared plus xh, all being divided by h. So I've rewritten it in this form. So we have as h approaches 0. Right. So we are going to get the limit of negative h divided by x squared plus xh. Then we now multiply it by, so because we have this h is the same as h divided by 1, so it's now going to be 1 divided by h. All right. As the h approaches 0. So let us continue to simplify. We start this h will divide itself 1, and it will divide this one, we get negative 1 over a. So it means we are going to get the limit of negative 1 all divided by x squared plus xh as the h approaches 0. Alright, so now we can take the limit as h approaches 0. So we are going to get, oh, sorry, so now we are only going to get negative 1, then whenever I see h, you put 0 over there. So we have x squared, then plus x multiplying 0. And this will give us negative 1 divided by x squared. So this becomes the derivative of the given rational function. So we conclude that dy dx of the given function is equal to negative 1 divided by x squared. Thank you for watching, and do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Thank you so much. Bye.